All right, geometry, ladies and gentlemen. What? That's my question. Not a lot of people actually attempt this one, which is okay. You were given the choice, and a lot of people took the top one because they were actually very similar. But the ones that didn't, again, I think were suffering kind of from a, well, how do I actually get to the proof of that these are supplementary? Which really, and if you watch more than one of my videos at this point, maybe this is getting tiresome, but hopefully it's tiresome the way it's getting repetitive and embedding into your brain that you really have to understand the structure, the diagram structure, because the structure is going to get you a relationship. Okay, that relationship is going to get you an equation, and that equation is going to get you a substitute and solve step to actually get you the thing you need. And so if you're looking at this and saying, well, I don't understand how to show the supplementary, that tells me that you have a misunderstanding in how this kind of general idea of proof is going to work. If you want to show that D and E are supplementary, my claim is you have to show that their sums add to 180. And if they do that, then by definition, they have to be supplementary. So if I'm looking at my givens, and really this is where we're going to start, my angle B is going to be 30 degrees here. Angle F is also going to be 30 degrees. And you have to show me that D and E are supplementary, the ones on the inside. Well, how do we do this? Well, we have to show that their sums somehow add to 180. Well, I mean, very kind of indirectly, or I'm sorry, maybe informally is a better term for that. If this angle right here is 30 degrees, well, wouldn't E have to be 150? And if this is 30, wouldn't that have to be 30? So if I can show that D is 30 degrees, then I can show that E is 150 degrees, and if I show that they add together to make 180 degrees, that should be your proof, guys. That's how we're going to do it. So let's review the plan, because if you didn't catch on, I just kind of revealed the general plan for our proof. First, we're going to show that angle E is 150 degrees, and you can kind of see how they form a line. That's going to be our structure. That means if they form a line, that means they're going to be supplementary. That's a relationship. That gives us an equation that we can substitute and then solve into. Up here, we got to show that D is 30 degrees, but if we're looking again at the structure, we can see the vertical angles. If they're vertical, they're congruent. If they're congruent, the measures are the same. Ladies and gents, that's going to be our proof. So for the very first proof in this video series, the very first question of this quiz, I used a form of proof that's more like a flow chart. The last one I did was going to be more is what we call two-column proof, which is a little more direct. It's a little bit less free-flowing, and you really have to have a good plan to use it. So I think for this one, I'm going to go back and do a flow-style proof, just so we can have some contrast in two styles. So let me get set up here, and we'll get right to the proof. So either case, whether I'm doing a flow-style proof or I'm doing one that is more two-column-ish, more listy, I do have to start with my givens. And even though they're written up here, just like any good story, guys have to get written in the story. So that's how I'm going to start. So the measurement of angle B is equal to 30 degrees. The measurement of angle F equals 30 degrees. Now, someone pointed out during the test that you do have one more given that these lines are parallel, but I don't know if that's really going to be or have a bearing on our proof at this point. We can add later if it does. But right now, let's start with these for our givens. And again, I'm going to put my justifications in a different color. So in this case, we'll show that our givens are going to be the two measurements of the angles. Okay. So I kind of divide this into two very distinct kind of sections. One, we have to show E is 150. Here we're going to have to show D is 30. So let's start down here with F and E. Again, structure first, then relationship. That gives us an equation that we can substitute and solve into. So if I'm going to start this proof and I want to show that in the end D is 150 degrees, I'm really going to have to start with the structure from the diagram. Again, I'm going to have to start with the picture. So how do F and E actually relate? Well, looking at the picture, F and E form a line. If they form a line, that means they're supplementary. That's by linear pairs. That's where I'm going to start with the diagram itself. So angle F and angle E are supplementary. And the way I know this, at least the way I'm claiming I know this for sure, is just from the diagram they form linear pairs. Hence, I'm going to quote the linear pair postulate. And again, I'm using abbreviations. Totally cool if you use abbreviations too. You don't have to, but it makes your job a little bit easier. Now, where am I getting this information? Well, that's coming from the diagram, not the given, so I'm not going to draw any arrows to indicate that I'm deriving that from something. It's a fresh idea that we're starting with. Now that I know the structure and the relationship are in place, I got that. It's in the step right here. Now I can extract an equation. Well, if they are supplementary, then their measurements should add to 180 degrees. So that, again, coming from the structure of the relationship, now we're dropping down to the general equation. We're not going to jump to the substitute and solve step, because that's going to leave a reason why. Like, where are you getting those? How do you know they're equal to 180 degrees? We're not going to jump there. In fact, instead we're going to keep the general one. And I know this equation is true because I established they're supplementary, hence definition of supplementary. Okay, in terms of connecting these ideas, where am I getting that? Well, that came from the relationship I just established in the previous step. Someone draw an arrow to indicate that this idea came from the one above it. Now I have my equation. Now I can do some substitution and solving. I can replace the values I know and hopefully get the values I need to continue my proof. So I'm just going to take this equation and modify it. I mean, that's really what substitution and solving is modifying an equation you already have. Hence why you have to have the equation first before you substitute the values into it. So what values do we know? Well, I'm told up here angle F is 30 degrees. So I can replace that one. So 30 degrees plus measurement of angle E is 180 degrees. And that's going to be a straight up substitution step. So in terms of like connecting these ideas, well, I modified the equation above it, and I use a substitution that I established in my given statement. Now here is all we have to do left to do is actually solve. We said we needed to show E was 150 degrees. Solving this equation, we can definitely conclude that the measurement of angle E is 150 degrees. Now if we're searching for a Y, we can just call it solve, because that's literally what we did. Come on, red pen. Okay. And in terms of connecting the ideas, well, I modified, or excuse me, I solved the statement right above it. Okay. Now we established now this 150 degrees. We're almost there. We now have to show that D is 30 degrees. But again, I can't jump just to saying, well, of course the measurement is 30 degrees. Logically, I know that's the truth, but I have to start with a structure. I have to start with a picture. That way no one can dispute why it's going to be 30 degrees. So in my picture, I can look at the angles themselves. Those are vertical. So the relationship I get from the structure is that angle B has to be congruent to angle D. And that's going to be because of the vertical angle theorem. Vertical angle theorem, of course, stating that if angles are vertical, then they are indeed congruent. Identified vertical angles in my diagram, therefore can conclude the relationship of congruency from my structure. Well, what next? Well, I'm trying to get to measurement to be 30, so I have to transfer this congruency statement to a measurement statement. But that should be pretty straightforward. If they are congruent, their measurements have to be equal, so the measurement of B is equal to the measurement of angle D. Okay. And that's going to be by the definition of congruency. And I modified the statement directly above it. Well, again, I was trying to show that measurement of angle D was going to be 30 degrees. Now I have this equality statement. Let's just go ahead and replace angle D with an angle value, angle value for B that I already established in my givens. In other words, 30 degrees is the same as measurement of angle D. My justification for that statement is going to be substitution. So last question answer is substitute from where using what. So the where from where is a previous statement. Using what was my given. Okay. Well, now I know that's 150. That's 100 and, or I'm sorry, measure angle E is 150. Measure angle 30 over here, or measure angle D, excuse me, is 30. That's what it means to be supplementary. They have to add to make 180 degrees. So I can start out with an equality statement. I know if I take 150 plus 30 degrees, that's going to equal 180 degrees. The justification here is one that we haven't used too much, but one that we certainly should be familiar with. I'm just making an equality statement. I'm just making a claim. I know if I take this, it's the same as 180, therefore an equation must exist. Now, that's not really coming from anywhere. I'm just making that statement because I know what I want to do my next step, which is to substitute. 150 is the same as measure of angle E, so I can do a replacement, measure of angle E. I know that 30 degrees is the same as measure of angle D, so I can again do a replacement. And again, I replace, so that's substitution. Substituted from this equation using these two values. Okay. Now, from here, I'm done. I need to make one more quick statement. I actually have to make my proof statement, but I've shown it. If I can show the measurements are equal to 180 degrees, then I can logically conclude that angle E and angle D are supplementary. And that's going to be by the definition of supplementary. Kind of reverse, but still the definition of. Okay. So it comes directly from the one above it, and that's going to be a good proof, guys. So again, over here, kind of stage 1 area. Okay, so over here in this kind of stage 1 area, that's where we show that this angle is going to be 150 degrees. Kind of over here in kind of stage 2, that's where you show that these angles are going to be 30. And then kind of bringing it together in the middle, showing the angles at 180 and therefore supplementary. So again, quite a few steps here, which I think this may be why some people shied away from it. But definitely doable given that you're using this idea, starting with the structure from the diagram, which shows a relationship, which gives you an equation that gives you an opportunity to substitute and solve that equation. Okay? So I hope this helps when you're making those corrections.